Phillip. Thank you very much.
Thanks. Hi, I'm Phillip. I'm doing product at Livepeer. Livepeer is a kind of platform as a service for video developers who want to add video to their application. And the key differentiator is that we are using decentralized infrastructures to make this a reality. This is all not that far. We have a proof of concept that's currently running on Ethereum, but we aim to a more scalable approach that's coming later this year. To do this, to allow video platforms to do their daily job, we are creating a new type of mining, the video mining. That's coming to cryptocurrency miners who use GPUs to do cryptocurrency hashing. And we aim to create an additional income for them. So if you're a developer who wants to add video to your application, you face a lot of pains, right? So it's really expensive to go after the services of the big five like Amazon or Google. Maybe not to start with, but once you scale your video infrastructure up, this is becoming really expensive. And on the other hand, you could self-host, get a bunch of root servers and manage them on your own. But this is hard to maintain, requires a DevOps layer that is most likely human resource intensive. To keep a system running stable at scale. If you do not do this, basically if you go to the cloud providers, you're also agreeing on renting the infrastructure from your competitor, right? If you want to create the next version of YouTube, it's kind of weird to go to Google and rent infrastructure from them. And there's like no alternatives available, so you couldn't just like go somewhere else. So with Livepeer, we are trying to create a marketplace, a trustless marketplace, so that anybody who has resources that he could contribute to a video network could share them. We are building orchestration services that are basically allowing you to share idle capacities in GPU mining rigs and other resources, and we would allow you to share them or sell them on a marketplace. So to do this effectively, we needed to create a sort of competition between the transcoders. So transcoders are the units that take a video and convert it in multiple resolutions so that they would run on any type of internet connection and any type of device that's out there. And the key for us was to find an unfair business advantage against other centralized providers who offer these by utilizing distributed infrastructures. So we basically give miners a new toy. They have previously been creating these mining rigs. I guess some of you have been in touch already. Containing out of graphic cards and a dumped down motherboard and CPU to just control the hashing on these cards. But what most people do not know is that in these cards, only parts of the chips in the cards are basically used for the hashing. Others are there for other purposes. For example, in NVIDIA cards, the NVENC decoder and the NVIDIA decoder and NVIDIA encoder are separate ASIC chips that are apart from the CUDA cores that would do the actual encoding. So you basically have in the lower part the CUDA cores that are being used for hashing. These are reprogrammable compute units. And then you have the NVIDIA decoder and NVIDIA encoder, and that's ASIC chips. So that's circuits that can't do anything else than video decompression, compression. So, there's a big price difference if you compare rendering video, encoding video on a graphic card, or if you render it on, say, AWS. On AWS, for rendering a live stream as we stream it from here on Livepeer, you would basically pay like $3 per hour. but the same graphic card or a similar graphic card in a mining rig would only produce an income of $1.50 in a whole day, while it could render 48 hours of video. So there's a huge difference in the price between those who basically do hashing and those who rent their capacities currently for video encoding. So, and as you see, the difference is huge. It's like 100 times bigger for the same service. The miners, on the other hand, have very low access cost to get into that game. Once our software is completely finished, they can run this side by side next to their usual hashing within their cryptocurrency mining bot. So they don't have to stop their usual operation. They can use the idle chips next to it in addition, basically. And that's giving them a second income stream. The resources that are available are massive. So as you see that in that picture, that's just one of the mining farms that Genesis Mining has, like a big hashing contract provider. There's a lot of them worldwide, but this is not only applying to the big mining farms, of course, but everybody could use that. In fact, the big mining farms will have less of an opportunity here, as they would have to spend dedicated resources in the form of bandwidth to do that specific service, while a home miner would basically be able to, utilize his already available bandwidth to contribute to that service. An institutional miner would have to get dedicated resources. So, of course, like if we give you a video and you encode it for us, we have to make sure it's properly done. If you don't do it properly, we couldn't really use it. So we had to design a passive validation mechanism to make this work. And that's basically a combination of like what's the encoding settings. So we use open source technology from the FFmpeg family to look into the video elementaries and see if certain aspects of the video job has been properly done, like is the codec properly, the bitrate, the frame size, stuff like this. But we also probe the video quality. So that's a tool that has been released from Netflix, for example, called VMAF. And what it does is it's using perceived video hashes to gain a metric on the video quality, or basically a score on the video quality. It allows us to see how well an encoder performed, so how good the quality was that he was producing. And it also allows us then to see if somebody cheated and tried to simplify the encoding process. And we have to see if the content was tampered, so if the content of the video itself was changed. And we use perceptual video hashing for that as well, where we would basically have a PSNR algorithm that's telling us if parts of the video itself or of single pictures in the video have been changed. That was an open resource topic for the last couple of months, but we were luckily getting into contact with researchers and developers from the FFmpeg community who volunteered to help us getting this built. So this is basically now in an alpha available with us, and we're not available for you, but we're testing it internally, hopefully soon for you. So these methods of validation basically allow us now to distribute video encoding jobs among any type of software. So the encoding software does not have to come from us. Same with chips. If there's somebody out there who's creating a new video encoding chip, which is like way more efficient, he can just contribute to our network without us ever touching his software. It's a complete passive validation. Before, we were using TrueBit, so before all the encodings that we've done have been CPU-based, and we were using TrueBit along with FFmpeg to really be able to validate if somebody has changed the encoding software. But that's not really helping with driving competition up, and that's what we do. We try to create a scenario where transcoders compete against each other for the available work in the network. We want to make them compete against price, quality, and performance. So price, we are creating a marketplace where it's not written in stone, we're just creating it where there's like a secret auction happening where you as the worker bid to get the work done. And if you basically broadcast or send a good price that the other party is willing to pay for, your chances, the likelihood of you getting the job is higher. Now, we're going to live in a world where there's so much more worker than available work that we think only the chance on changing your price and bidding for the work is going to allow a huge competition on the price. I come from a centralized company that is doing encoding services since quite some time. I've started with a small startup with friends in 2010, 2011 here in Berlin to do this, and sold this a couple of years ago to a US company. And I know that there's always going to be that threshold that none of the companies want to step over in terms of price, as their onboarding costs for their customers, their support costs, they're much higher than the actual infrastructure or the operational cost. So, they will never allow a certain price thresholds to be broken, and there has to be like an automatic software doing the price negotiation, so though that there is not so much room for price cartels building in that space. And quality, we want to allow that transcoders are able to broadcast a higher price if they do a better quality. But we also want to allow older equipment to be able to do the video processing for networks that are not able to sustain a higher price. Not all video use cases are the same, right? You have video use cases where there's a real business model behind it, and though the video developer who is implementing it can pick more expensive but maybe better looking technology or more performant technology, but we also have markets where there's no business model and it's subsidized anyways, so the more money they save along the way, the longer they can run. Having now a marketplace that allows people to bid on both price and quality is going to allow the different markets to access the same marketplace. Amazon sells the encoding for the same price for everybody, right? But there is businesses out there, let's say India or somewhere else, where the business model behind these video use cases might never achieve the equilibrium that we see happening here in the Western world. So, and performance is the last. So we create race conditions among transcoders to make sure that there's at least one really good performing transcoder who can then win the job. And we do this so that even so it's a distributed network, we give you some confidence that we will always have your encoding or your live stream being maintained on a professional level. There's in the end then not a single point of failure, but at least one transcoder still carrying your stream. The result would be that there's a dramatic cost reduction. We say we can get to 5% of what the market price is today. From a $3 per hour price, we think we can drop to 6 cents. That's not us or our cut, of course, that's the net income of what a transcoder would does. Livepeer does not have a plan to create a fee market on top of that. So it's just going to be an open source market that anybody could use without a middleman that's gaining fees on top of it, other than the actual transcoder and infrastructure providers. We want to make sure that the overall quality is getting higher and higher over time, so the competition itself should also incentivize transcoders to broadcast higher quality encoding jobs for a smaller price, and also higher reliability. Currently we say reliability is going to happen in our world through redundancies. We're going to have multiple production lines working simultaneously, basically, so one can fall off without harming the overall result. So the market size for transcoding, it's something that we can easily calculate through. So YouTube doesn't have public numbers, but in some of their press releases you can hear them saying we do 300 hours of video every minute, and that sums up to 18,000 concurrent live streams. Now, with each NVIDIA graphic card being able to render 2 streams, you would only need 9,000 of these cards to always render all of the incoming videos of YouTube in real time. So it's not really saying that we aim to do this, it's just to give you a perspective on how much resources are actually needed to do the job. It's not that much. With Twitch, for example, you see they peak at 75,000 concurrent channels. It's not even that all the Twitch channels would get a transcoder. Only their partner programs member or only those viewers who have above 50 concurrent viewers would actually get a transcoder. But still, like 35,000 cards would be enough to render all of this in real time. So now take the Ethereum network. The Ethereum network, if you take the hash rate it has and divide it on how many graphic cards you could run with it, you would end up with about 6 million graphic cards, NVIDIA graphic cards, doing that job. So alone with the Ethereum proof-of-work hash power or the ASIC idle chips that are next to these graphic cards, you could basically render about 12 million concurrent live streams all the time. That's way more as the worldwide demand is. So that sounds like a business threat, right? But it's really not. So that's not a business threat for the enterprise customers. It's a very overserved market with encoding or video in general. They have specialized on niches in these enterprises to sell into certain verticals. We are all not addressing this, and they're also from a cost perspective not at that point where they desire a dramatic cost decrease. So that's not for the enterprise. It's also not for premium, right? Netflix encodes every video it does a few hundred times. It's literally brute forcing the encoding results to get the best possible outcome. So also premium content providers, it's not going to be interesting for them. And even for the traditional broadcasters, so the German television, they won't be interested. They have their encoding solutions. But what it really does, it's creating a new market for decentralized applications that first need a decentralized infrastructure to not lose their habits, right? And also to have a dramatic cost decrease here. We have all heard about startups who were lucky and got some venture capital or some funding, and then they started to create a video product and just drain through their resources really, really quickly. I've seen that happening myself a couple of times, where people had good ideas and even good funding, and they started, then they had a sudden success. A lot of people were consuming their content or using their app, and they were not able to build up a business model before they ran out of their funds. Now that's a huge risk, and lowering the cost of the operation just means giving them a longer runway. If we are at 5% of infrastructure cost for running a video platform, it also means for somebody who's implementing that and using his capital against that service to be able to run 20 times longer. So that gives him a lot more time to find a real business model and then hopefully sustain and be able to compete against those who have the infrastructure already. Right? So this is targeting consumer products, most likely consumer products that are not yet having a business model and trying to maybe over time find one, but need a long runway to find it. It's in a sense, it's a sense where the competitive market is going to create a different niche. It's not a horizontal retarget. It's really it's not really a vertical retarget. It's really horizontal for anybody to build on. So maybe over time we're going to see people from the traditional enterprise maybe pick up our use case once it fits, but it's not their primary goal. So that's it. Thank you very much for listening. I ran through it very quickly. Is there any questions?
I'm not so familiar with the transcoding thing, but you said like in Twitch, in some channels, they don't need a transcoder, they cannot access a transcoder. What does it mean then, that it's not possible to stream to certain devices?
Yeah, correct. So in Twitch, if you are a nobody, if you're not yet in their partner program and you have less viewers, your highest quality is the quality you broadcast. You only send them one stream. And that is what everybody has to consume before a transcoder kicks in. So anybody who is in the situation that he could currently not sustain the bandwidth from your source stream would not be able to properly watch that stream.
Because the source stream would most likely be high quality.
Exactly. Yeah, you try to send in the best possible quality so the viewing experience is good, right? But you need the transcoding to sustain then the various internet connections and devices that are out there.
Okay, thanks. Interesting.
Yes? Bandwidth is a limiting factor, and similar to how it worked with proof-of-work mining, where you, as a miner, had to find a affordable resource of electricity, now miners have to find affordable bandwidth as well. We estimate with about 10 megabits up and download capacity per encoding job you do. That's including a headroom. Yes? Yeah, the question was if we ask for fees, but no, we will not ask for fees. The aim for Livepeer is really to build an open source community around this that can sustain. We have created a token that's being used as a utility token to secure our network from Sybil attacks, but it's also not going to be used to pay for the service internally. It's going to be ETH, basically, that you use to pay for that service, and the Livepeer token really is only to basically secure who is allowed to do work in the network. Could you repeat that a little louder, please? So the Livepeer product has been funded with a private token sale that will give us enough headroom. It's about 4 million, enough headroom with our small team to build that product, to get it out the door, and to get it running. And it most likely is also enough to sustain this for 1 or 2 years, to maintain it and to continue going. But the aim of it is to become a more decentralized organization in the end that is not depending on direct finances, but would basically ask those who use that network to contribute also to it. The Livepeer token itself definitely will have some value. In my sense, it acts also as a type of software license, but that's not really, it's not really true, right? Because you could scale behind a single license as well. But in the end, to do work in the network, or basically to do validation work in our network, at some certain point in the future you're going to need the Livepeer token, and that's also going to give him some value depending on the adoption and use. Yes, please. Could you repeat, please? So we are using a delegated proof-of-stake system. No, we don't. So proof of bandwidth is something that I have heavy doubt it's ever going to work out, because it's so easy to emulate traffic. In that sense, I think we will not build our own peer-to-peer CDN, but rather integrate with existing projects, like, for example, the Swarm project. So there is existing projects out there that are trying to get like a proof for replication done. And the Swarm system, for example, used that methodology, swap, swear, and swindle, to mitigate the risk that you have for somebody not being able to pay you for the traffic that you served. But all these concepts are highly experimental, and none of them are yet proven to be working or to be easily to integrate. And with us, like with video infrastructure, it's our on or off game. Either this works or it doesn't work. Like with video, you have very little room for users having a bad experience and still accepting the service. Especially if you look at YouTube, Facebook, Twitter, also Netflix, what they do to improve the viewer experience today. Anybody who wants to compete in that has to at least do similar well. So we are basically currently exploring ways for the delivery that are not relying on a financial layer, but are more a free service. We are currently experimenting with web torrents, using HTTP traffic next to it to sustain a live use case. So you would basically have a CDN on one side, a traditional CDN, and you would have a web torrent stream on the other side. And clients would basically be allowed to get partial data from the CDN and partial data from other users that are currently consuming the same content. That's, with us, it's very a good situation, because with live stream, you're like the only use case where really everybody is getting the same content at the same time. So for us, it's working out pretty well. It's different for other use cases, especially long-tail use cases can't really use this. But yeah, we're looking into how to make this work as well. Our goal is not only to drive down the pricing with transcoding, but our goal with Livepeer is really to drive down the price for overall video infrastructures. Cool. One more? So currently the whole job negotiation and anything else works on chain. That doesn't give us a lot of room for many transcoders. We currently only have 15 transcoders that fight for the jobs in the network, but that was just a proof of concept design. Later on, we think about having a limited amount of orchestrators or validators that are basically sitting in between the transcoders and those who buy the transcoding resources. That would mean that the validators might still be limited, but they don't do the hard work. They only do partial work, the validation work, and the real work happens with transcoders, and that's then all off-chain and unlimited with the amounts. Or it's limited, of course, with the physical resources behind it, but it's not limited as it doesn't require us to go through Ethereum each time we do one of these jobs. Yeah, you're hitting a point there. So yes, you're right. To make video ingest a success, you have to make sure that you're not too far away from the origin. And one of the new network layers includes a region, so that you would basically broadcast the availability of your work in a certain region and would not then get a job from Tokyo or from China. Yes? So currently it's with x264 and the software encoding, it's really only CPUs. Later, with the GPU-based verification, we're going to do AMD and Intel. That's coming to VA API and NVIDIA, and that's basically covering any graphic card provider out there, and even the graphic chips that are in the Intel CPUs. We are discussing if it's also needed that we would go to a more ARM kind of infrastructure and see if we can get even PI boards in. I mean, there's so few so few devices out there that do not have a video encoding chip in the meantime. It's crazy. Most likely even your television has one, even so it's not used. Yes? Could you repeat, please? Sorry, I don't understand. Oh, I'm not part of that decision. I joined Livepeer when that decision was over. In my mind, I say, so how do I put this without stepping on somebody's toes, right? So building apps on Ethereum is really a bad idea right now, right? What I would need to get the original design to scale without us doing a huge protocol redesign and without us pushing everything off-chain would be a fixed transaction cost. But I think that's never going to happen, and for known reason. So why we chose Ethereum? Because of the smart contract platform. that's unmatched still. Is it the best place for us to be? So for me, as like the product guy, I'm really not convinced. I see so many reasons why we should not. Our smart contract developers are very confident that we can push anything that's bloat right now off-chain and make sure that these use cases then only need Ethereum as the financial settlement layer and basically to do the proofs and challenges that would reveal a cheater in our system. Yeah. Thanks. Cool. Thanks.